Imagine you are walking on a frozen lake. The ice feels solid beneath your boots. You can run on it. You can build a house on it. It feels permanent. But deep down, you know the truth. The ice is just a thin layer. Beneath it lies a deep, cold ocean waiting to swallow you. The only thing keeping you safe is the temperature. Physicists have begun to suspect that our entire universe is like that ice. We think the laws of nature are solid. We think reality is stable. But we might be wrong. We might be living on a thin layer of stability, hovering over a deep abyss of nothingness. And at any moment, the ice could crack. To understand how the universe could end, we first have to understand what nothing is. We tend to think of a vacuum as empty space. If you remove all the air, all the atoms, and all the light, you are left with nothing. But quantum mechanics tells us this is a lie. Space is never empty. It is boiling with energy fields. Virtual particles pop in and out of existence constantly. The vacuum is simply the state where these fields are at their lowest possible energy. It is the ground floor of the universe. Or at least, we hope it is the ground floor. One of these fields is special. It is the anchor of our reality. It is called the Higgs field. Think of it as an invisible ocean that fills the entire universe. As particles move through this ocean, they experience drag. This drag is what we call mass. Without the Higgs field, electrons would have no mass. They would fly apart at the speed of light. Atoms could not form. You could not exist. Everything we are depends on the specific energy level of this field. So, how stable is this field? Physicists use a simple metaphor: the valley. Imagine a ball rolling down a hill. Eventually, it settles at the bottom of a valley. It stops moving. It has lost all its potential energy. It is stable. This is the state of our universe right now. The Higgs field has settled into a valley. Because it is at the bottom, the laws of physics are set. Chemistry works. Biology works. Gravity works. We are comfortable in the valley. But here is the terrifying question. Is this the bottom valley? Or is it just a ledge? If we are at the absolute bottom, we are in a true vacuum. We are safe. But if there is a deeper valley nearby, then we are in a false vacuum. We are not at the bottom. We are just stuck on a shelf. We have potential energy that we haven't released yet. The universe is technically metastable, like a boulder balanced on the edge of a cliff, waiting for a tiny push to send it tumbling into the dark. For decades, the false vacuum was just a scary campfire story for physicists. We didn't have the numbers to prove it, but in 2012, that changed. At the Large Hadron Collider in Switzerland, we finally found the Higgs boson. This was the missing piece of the puzzle. But when we measured its mass, we got a number that made cosmologists sweat: 125 giga-electron-volts. If the mass had been lighter, the universe would be stable. If it had been heavier, it would be extremely unstable. But 125 is right on the edge. It suggests we are living in the Goldilocks zone of danger. The math indicates that a deeper valley does exist. So why haven't we fallen in yet? Because we are metastable. Think of a boulder balanced on a high ledge. It isn't falling right now. It could sit there for 1,000,000 years. It appears stable, but it is not at the bottom of the canyon. All it takes is a single push, a tiny amount of energy in the right place to knock it off the ledge. Once it starts falling, it won't stop until it hits the true bottom. Our universe is that boulder. We are balanced on a knife edge of stability. In the classical world, the boulder needs a push to get over the hill, but in the quantum world, particles can cheat. This is quantum tunneling. According to quantum mechanics, a particle doesn't have a fixed location. It has a probability wave. Occasionally, a particle can simply teleport through a barrier. Shutterstock. This means the universe doesn't even need a push. It is statistically possible for a tiny point in space to simply tunnel through the energy barrier and drop into the lower valley spontaneously. It doesn't follow the rules of logic. It follows the rules of chance. This event is called nucleation. It creates a bubble. It could happen anywhere. It could happen 1 billion light years away in a distant galaxy. Or It could happen in the room with you right now. It starts at a single point in space, a microscopic spot where the Higgs field suddenly drops to a lower energy state. It creates a tiny sphere of true vacuum. This is the bubble of death. Inside the bubble, the laws of physics are rewritten. The energy level of the universe is lower. Outside the bubble, the laws are normal. Separating them is a wall of energy. The bubble wants to grow. It must grow. Because the inside is lower energy, the bubble expands outward to consume the high-energy space around it. It is a fire that uses the universe itself as fuel. If this bubble forms, can we run? Can we send a warning signal? No. The bubble expands at the speed of light. This is the ultimate trap. Because information travels at the speed of light, no signal can outrun the bubble. You cannot see it coming. The light carrying the image of the bubble arrives at your eyes at the exact same moment the wall of the bubble hits your body. One moment you are looking at the stars. The next moment you simply cease to exist. There is no pain. There is no fear. Just an instantaneous switch from is to is not. What is the wall made of? It is pure energy. As the universe transitions from the high valley to the low valley, it releases the difference in potential energy. That energy is concentrated entirely in the shell of the expanding bubble. It is a wall of infinite heat. Anything it touches, stars, planets, gas clouds, is incinerated instantly. But incinerated, too soft a word. Fire just rearranges atoms. This wall deletes them. The true horror is not the wall. It is what lies behind the wall. Inside the bubble, the Higgs field has a different value. This means the standard model of particle physics is rewritten. The mass of an electron changes. The strength of electromagnetism changes. The speed of light itself might change. Chemistry depends on electrons orbiting protons in very specific shells. If you change the mass of the electron, atoms cannot hold together. Molecules shatter. DNA dissolves. Inside the bubble, biology is physically impossible. It is a universe where life is against the rules. It gets worse. Some theoretical models suggest that the change in energy would drastically alter gravity. Inside the new vacuum, gravity might become overwhelmingly strong. The moment matter enters the bubble, it doesn't just dissolve, it collapses. Every star and planet would be instantly crushed into a black hole. Or gravity might become repulsive, tearing the universe apart into a thin mist. Either way, the structures of the old universe are gone. We often talk about the end of the world as a tragedy. But vacuum decay is not a tragedy. It is an erasure. If a nuclear bomb destroys a library, the ash remains. You can analyze the ash. You can say, a library used to be here, but if a vacuum decay bubble hits the library, the information is gone. The physics that allowed the book to exist are gone. It is the universe's delete button. History, memory, love, hate, science, erased as if they never happened. It creates a perfect, sterile silence. So is the bubble forming right now. Or worse, could we create it? Some theories suggest that nucleation requires a high-energy trigger, like striking a match to light a fire. Scientists have worried that high-energy particle collisions like those in the Large Hadron Collider or the final moments of a black hole evaporating could provide enough energy to tunnel through the barrier. But nature provides a comforting counter-argument. Cosmic rays particles moving much faster than anything we can build have been smashing into the Earth and the Moon for billions of years. If high-energy collisions triggered vacuum decay easily, the universe would have ended long ago. The ice is thin, yes, but it is surprisingly tough. There is another safety mechanism: dark energy. The universe is expanding, and that expansion is accelerating. Because the bubble of death expands at the speed of light, it has a speed limit. But the expansion of space does not have a speed limit. If a bubble formed 10 billion light years away, it would never reach us. The space between us and the bubble would stretch faster than the bubble could grow. We are in a cosmic race, and as long as the bubble starts far enough away, we win. So should you lose sleep over this? The probability of a quantum tunneling event is astronomically low. When physicists run the numbers, the expected lifespan of our false vacuum is likely trillions of years. The universe has survived 13.8 billion years without popping. It is statistically almost certain that the stars will burn out, and the black holes will evaporate long before the vacuum collapses. We will likely die of cold, not of deletion. Unless, of course, someone gets careless. We return to the Fermi paradox. Why is the universe silent? Perhaps vacuum decay is the ultimate great filter. Maybe advanced civilizations inevitably build particle accelerators powerful enough to pierce the Higgs field. They try to unlock the secrets of God and accidentally trigger the nucleation event. They don't just kill themselves, they delete their entire local cluster. Perhaps the silence of the night sky is the silence of a graveyard that has been wiped clean. But there is a strange comfort in this theory. Most ends of the world are painful. Asteroids, plagues, wars, freezing. They involve suffering. They involve fear. But vacuum decay. It travels at the speed of light. Your brain processes visual information slower than the speed of light. If it happens, you will never see it. You will never feel it. You will never know it happened. One moment you are. The next you are not. It is the most perfect, painless, and absolute death imaginable. So don't worry about the bubble. If it's coming, you won't be there to mind.